Here are two questions based on turning points and zeros of polynomial functions. We have purposely taken two different types of examples. One has got even degree and the other one has odd degree. And let's try to understand what happens to their turning points and zeros. Question number one. Write all possible answers for an octet 8-degree polynomial function. Number of turning points and number of zeros. These are the two things which you have to give for octet, that means 8-degree polynomial. So you should remember one thing, that whenever we have an even degree function, since even degree function has to go from quadrant 2 to quadrant 1, it should at least turn once, right? So the minimum number of turning points for any even degree function is always 1, right? So we say minimum is 1. So we say 1 is minimum number. Let me say 1, right? Now, if octet degree function turns once, then it will go there. But if it turns next time, it will land up in quadrant 3. But finally, it has to reach there. So it will turn in one more time. So it turns in pair thereafter. So once it turns, after any turn, it has to turn again. So it turns in pairs thereafter, right? So next number of turns cannot be 2, but they will be 3. Do you understand? Likewise. And maximum number of turning points can be how much for any function, even or odd? Maximum number of turning points is always n minus 1. So n minus 1 for 8 is this. So it goes 1, 3, 5 and 7. So these are possible number of turning points for an octet function of degree 8. Right? So they have odd number of turning points, right? Now as far as zeros are concerned, well, the function could have been like this, right? Without any zeros. Since they are moving from quadrant 2 to quadrant 1, so number of zeros could be 0, right? Or if it touches at 1 point, 1. Maximum number of zeros are how much? Maximum number of zeros are equal to the degree. So there will be 0, 1 or 2, 3, 4, 5, 6, 7 or 8, right? So number of zeros, as far as number of zeros are concerned, number of zeros are always from 0 to n. And number of turning points are actually for even odd numbers, right? But we can write maximum number of turning points are n minus 1 for both, right? Well, as we have seen, number of turning points for octet degree is 1, 3, 5 and 7. Now let's look into heptic and odd degree function, right? We have already considered even degree function. Odd degree functions have to go from quadrant 3 to quadrant 1, right? So they can go without turning. So the minimum number of turning points for odd degree function is always 0. Now, as we saw earlier, if it turns, it has to turn again, right? If it turns once, then it has to turn again, because finally they have to reach there. So set of 2's, they turn in set of 2's, right? So the number of turns a 7 degree can have is 0, 2, 4 and 6. Do you understand? Not odd number of turns. Now number of zeros. Since it has to cross x-axis, there is at least 1 0, correct? And maximum number of zeros could be the degree of the function. Therefore, possible zeros are 1, 2, 3, 4, 5, 6 and 7, right? So those are the possible zeros. So you learn that maximum number of zeros and maximum number of turns we can write here, right? We'll write maximum turns are how many? For octet, maximum turns are n minus 1. And minimum for octet is they have to turn at least 1. Okay? And as far as zeros are concerned, this is about turns, right? Turning points. And as far as zeros are concerned, right? Maximum number of zeros are equal to the degree, and minimum is 0, correct? How about odd degree function? As far as turning points are concerned, maximum is, as you can see here, maximum number of turns is n minus 1. And minimum is 0 because they can go without a turn. As far as zeros are concerned, maximum is n, just as here, right? But minimum is 1 because they have to cross x-axis. That's the summary, and you should remember this because that's very important to sketch any polynomial graph and to recognize the graph also. Thank you.